Essentially. Sure. In this today's session, we'll go through basics of PyTorch. So hope everyone has Google Colab ready in your system.
Yes, sir.
Okay. My screen is visible, right?
Yes, sir.
So anyone has used PyTorch before?
No, sir.
So you don't have any experience in PyTorch. Okay, fine. Have you heard of this PyTorch before?
Yes, sir.
Yes, sir.
Okay. So can you tell me you heard this one, right? So where it is used and any idea? Just little bit. Just share what you know.
So, I like what I know about it is that it's used in building machine learning frame like models and all. Back when using teachable machine, I heard that it used TensorFlow. Then I was learning a little bit about it and heard that PyTorch is also another such thing like TensorFlow. So that's what I know.
What you told is completely true. So this is one of the framework used for machine learning. So it uses similar to your Python language itself in order to build models, train the models, do machine learning and AI operations. So this is most popular deep learning framework. So so since you have not worked, right, so don't worry about that one. So this is about the basics, and we'll go through each and everything, like how to create neural networks, how to train, and how to classify and do the operations accordingly. So PyTorch, it's as I told, it's an open source machine learning framework. It was developed by Facebook AI Research Lab. So it has been designed to accelerate the path from research prototypes to production. So if you see in TensorFlow or something like that, so it's used for research and research prototypes and used to build models for your production code, right? Similar this way. PyTorch is also used for your open source codes and everywhere. So what key features PyTorch are that it has built-in Python code and easy installation. Sorry, easy integration. So, since you already know Python, right? So you should be able to understand most of the things. And one more PyTorch is good is that it uses computational graphs. So these are dynamic. So once if training is going on, right? So right hand side in the graph, you can see how it's training and those kind of things. So it's kind of live graphs you're getting, and it will be easier to debug if you have this option and so on. And one thing notable is that most of your systems won't be having GPU, right? GPU is nothing but your system's graphics card. So GPU, if you have, it's well and good. But since we are using Colab, we'll utilize that one itself. So why did we choose PyTorch? Because as I told, TensorFlow, you don't have the flexibility to manipulate each and every layers, everything in TensorFlow. It's kind of limitations for the developer to develop something in that. So PyTorch has more advantage when coming to creating everything from the scratch and doing all the operations. So one reason why we use PyTorch, and it coming into if you can see from the PPT, Other things are like it has, as I told, it has that dynamic graphs. So it has natural Python syntax. So if you know Python, it's easier for it to understand. Third thing main I'll tell is that using PyTorch, it's research friendly, as I told. PyTorch gives you like more flexibility for the developers to handle each and every layer in models and whatever you defined, right? So this gives you flexibility. So you can go to any place and you can edit anything. So that flexibility is not there in TensorFlow. And also like since most of them use PyTorch, right? So there is a strong community. So you can get help anywhere if you are stuck because most of them use PyTorch itself. Okay, so in your Google Colab, so like we'll install some Torch Vision and Torch Audio. Like these are the things which we require. So for today's session, uh, you can do pip install Torch, Torch Vision, and Torch Audio in your Google Colab. Okay. Now just a minute. I'll share the screen. So start a new notebook. So I'll just rename it as PyTorch class 1. And I'll share this with you also later. You can refer this one. So everyone created your Google Colab notebook.
Yes, sir.
Yes, sir.
Once done, like just install this one. Stop. So I'll share this in the chat also, like you can just copy. So if requirements already satisfied, then it's fine. So this one was prepared like as I told in before, right? We will use Anaconda since most of you don't have this CUDA or GPU in your system. So we'll go for Colab. So once installation is completed, right? Just we need to check these two comments. First is that we need to import Torch. You can see like 2.810, right? CUDA 126. So if you're getting, it's well and good. Everyone is getting right. So import torch, print torch dot underscore underscore version. I'll just share this also. Everyone done?
Yes, sir.
So how many of you remember NumPy? Anyone NumPy? You like? Can you explain like or else just tell in short what is NumPy and what you did?
Sir, may I?
Yeah, sure. It's for everyone. Like you don't
Yes.
have to ask.
Sir, NumPy is a full form is numerical Python in Python library used for working with numbers and data in arrays. It one of the most important tools for scientific and data computing in Python, sir.
Yeah.
Yes.
So what is true? So NumPy are like kind of arrays. So similar to NumPy, like in TensorFlow, we use tensors. We call them as tensors instead of NumPy. So these tensors are like multi-dimensional arrays. I told you, right? 3 channels, 4 channels, like n dimensions. So these are multi-dimensional as well. So the key difference is that this tensors, like they'll run on GPUs and they'll give a boost for training your systems and everything. So one of the major advantages of using tensors. So you can just convert whatever numpy is there, right? You can just convert it to tensors using 1 or 2 lines. That's it. So like creating tensors is just like you're creating numpy. Torch.tensor, if you create 1, 2, 3, so it will create 1, 2, 3. Yeah, Abhishek.
No, sir.
Okay, so I think it was some background noise. Okay, fine. So you can just create one small tensor. X is equals to torch.tensor 1, 2, 3. So just try this one. Random will print this one. So x is equals to torch.tensor, right? So it give you as tensors 1, 2, 3 array has been created. So it's just np.array is there, right? How we create np.array instead of that one, torch.tensor. So instead of np we are using torch, and instead of array we are using tensor. So and we are giving the array inside a bracket. So then we'll create a multi-dimensional array, right? So one more we'll create. Is equals to so randomly it created from 0 to 1, taking that as minimum and maximum value, and it created 2 rows and 3 columns. So torch.random 2, 3. So 2 rows and 3 columns it created. So similar thing we did in NumPy, right? Same thing we are doing in TensorFlow. Sorry, PyTorch tensors. Then what was the other example? So torch dot zeros, if you give, it will create all zeros. Set is equals to seven. So similar way, like we'll create identity matrix and so on. Like we can do the same like how we did for NumPy, right? So similar tensors are also same. So only thing is that tensors are optimized to run on your GPUs. So any doubts on this one? Creating tensor arrays?
No, sir.
Everyone completed with this, creating simple outputs?
Yes, sir.
Yes.
So similar to NumPy matrix operations, so we can do the same for tensors also. C is equals to A plus B and multiplication, reshaping of tensor slicing, we already did, right? So just skip for this one, like you can try it out. So take it as an assignment and complete before next class. So operation is simple. So create tensors, do some addition and multiplication, subtraction and division, and do the matrix operations also. So we did the similar one in PyTorch. So anyone heard about this autograd or automatic differentiation? So I'll just explain. Autograd, like this is just PyTorch differentiation engine. So you can perform multiple operation on tensors. So once you've done something, right? So if you do multiplication or if you do some computation, so like it will automatically records these operations in like as a graph it will do. So for that reason we call this as autograd and automatically it does. So there is one thing if you see over here. So we have created extensor required grad and we are doing some mathematical equation over here, right? So when we do y dot backward, so this PyTorch will automatically computes all the gradients in it. So you don't have to define like, for example, this backward is like going back in the neural network. You're trying to have some memory stored or some data retained. So if you do backward or something like that. So this is like when you define any model, like it's the easiest way. So PyTorch gives you this computes all the other things which is required for models and it automatically gives you like kind of all the values instead of you doing everything. But whatever it does, right? So you can just control this, the flow, everything in PyTorch. So this is just simple y is equals to x squared. Then we are calling this backward, right? So algebraic equation x square, y is equals to x square. And then we are trying to do backward. So this computes all the derivatives of x. So for example, x it will take, right? So you don't have to define x every time and so on. So 2.0 and so on. So it calculates as 4 when x is equals to 2. And like if you want to do more or something like that. So if you want to return and those kind of things. Derivatives of, there is one more thing. This one, like when you do backward also, right? So it will give you that gradient. So training neural networks, like it's like really important. So it will give you the derivative as well. So we did x square. So we got when we take 2, we'll get 4. If we take 3, we'll get 9, right? So if you have that 9 or something like that, so this one would also have the values of derivative where it came from. For example, it came from 3 square. So 3 also it will keep track. So for that reason, we'll use this backward. So it will have all the knowledge retained. So for that reason, we'll use backward. So you can try this out as well. So x is equals to torch.tensor 2. So just defining one value for x as a tensor. And then requires grad is equals to true. So gradient whether we require or not, you're just defining. Then x is equals to x, y is equals to x square we're doing. So any doubts if you had, you can ask me now.
Sir, like, can you once again
So like if you have done some operations, like you need to have some kind of have the knowledge, right? So where it came from, like in whatever you do in Python, so you just look for the output. So but Python doesn't keep track of what and all you did. So when you use this backward, right, so it keeps track of like what and all operations you did. So for that reason, like we did, so it will retain like x square we did. So it will also try to calculate the derivative of this one and just give you the operations and all. So for that reason, we use backward. So it's just like automatic differentiation machine, so that it records all your operation. That's it. So that is what autograd is. So like input you'll give, you'll do some operation and you'll get the output. So in Python, you'll leave at this output. So but in autograd, what it does is like, so it will keep track of this operation and whatever the input you give also. Like you got to know like what I explained. Abhishek.
Yes, sir. Yes, sir.
So in this, like whatever autograd is there, right? So backward, so just keep tracks. That's it. So of your computation. So it's really important, right? So whatever you're doing, the system has to know like what it's doing really. So for that reason, we'll use autograd. So 2.0, or else I'll give it as 5 or something. And then we do require this autograd. So requires grad is equals to true. We have to define. So do we need this autograd? So also like we have to make sure like we are telling this model like whether we require this autograd or something like that. For that reason, we are using this line. Sorry, I did a mistake. So it has to go to the same line. So it's the same line. So for x only, we are defining this one. So print x. So this is a tensor file, and we're telling autograd whether it requires or not. So then we'll do y is equals to x square, right? And y dot backward, and we'll try to print the x grad. We'll see. Oh, this is multiple of 2, right? So let's see. So square we have now we take square. Okay. That was basic about AutoGrad. So I'll just teach you like how we create a simple neural network.
Excuse me, sir.
Yeah, Tanisha.
So can you show the slide? Oh yeah, thank you.
Sorry, everyone completed, right?
Yes, sir.
Excuse me, sir.
Yeah, Kundan.
Sir, I'm Kenneth. Sir,
Okay,
I
so
tried this. Sir, I tried this code, but I'm not getting it, sir.
what are you getting? Like, can you share your screen? Just a minute, stop sharing.
Yes, sir.
Yeah, you can share your screen.
Sir, I'm getting an error.
Okay, 1 and 2, can you see what strong you did? 1 and 2. Line 1 and 2.
Okay, so yeah, so I change the variable. Yes, sir, I got it.
So that was like keeping track of things. So like in order to build neural network models in your PyTorch, right? So there are some syntax you need to follow. So this one like simple PyTorch, so defining neural network models and how to return those. So we have learned about classes and functions, right? So class, you're creating this one neural network module. So you're creating a function, defining it, and then you're creating whether it has to be feed forward network and what type of network it has to do. So for that reason, we try to define some functions. So coming into few things like which I wanted to mention was that, so in the initiate method, init is there, right? So this one init method. So you'll define all your neural network layers. So this would be like your fully connected layer, DNN model, Google Net model, AlexNet model, or something like that, whatever you're designing your model, right? So it will come under INIT. So make sure your model layers comes in INIT. So inside this function, right, INIT. So all of your layers of your models comes. So if you see over here, FC1, so this is fully connected layer 1. So we'll just self-define and call it as neural network linear model. So this one is nothing but what the input array size is. So don't worry about this and all, like as we go on next classes and upcoming classes, right? I'll just teach you in more detail like how we define and those kind of things. As of now, just get the idea like what this is about. So this is just the basic, right, for today's class. So just keep it simple and we'll go in deep into next class, like what this number is, what this nn dot linear is, self dot fc, like we'll see in next class. So don't worry about that one. So if you see over here, so inside in it, all the layers of your neural network model will come. And then in the forward method is there, right? So all the parameters like your activation function, your whatever the management for your neural network. So everything would come under this forward, define forward. So it's moving forward. So you're giving input, it has to give output. So inside this define forward, everything has to come like operation, what it has to do. So once you have defined this way, right? So PyTorch will automatically handle all the parameter management, everything it does automatically on its own. You don't have to keep track of anything or something like that. You don't have to define any other function. You don't have to like calculate something or something like that. So once you do this way, right? So PyTorch will automatically get all the parameters like whatever you're trying to do. So in order to explain these numbers, right, I'll just simply explain like what it is. So this is simple feed forward neural network model. So it takes 784 inputs. So this has been like kind of, how do I say? So 28 cross 28 matrix is there. So those are images, some images. So that is, have you heard about MNIST data set? So those are like, some of them are 28 cross 28. So those are the pixel size of the images. So this would pass through 128, sorry. So 128 is here, right? So this would pass through 128 neurons. So 28 cross 28. So those images, there will be 128. I'll just show it to you, representation. Is that right? Size will increase. Okay. So this is 28 cross 28. So this whatever image is there, right? So these are neurons. So we call them neurons in hidden layer. So you have the ideas of what neurons in neural network.
So it's like there are multiple layers and of processing between the input and output.
So what I told is true. So this like neurons is nothing but like, so what action has to be taken, like it would be decided in this each neuron. So there will be 128 such. If you consider from here to here, right? So there will be 128 according to the defined neural network. So one more layer we have defined. So a fully connected layer 2. So it also has 128 inputs and 10 outputs. So coming into this one. This one has only, we take this one, right? So this one has only 10. So this has 10. So 28 cross 28 image would go into 128 neurons. Once again, it will pass over there. This is feed forward, like it has to go to the same put. So there are multiple types of neural network models. So depending upon your model, like the action depends. So and whatever it comes, so outputs, so it would be connected, fully connected. So everything would be connected to each and everything. And then this is the output and it will decide your output classification. So this is just the simple neural network model. So just don't try to like overthink or something complicated. So this is just for your understanding. I'm explaining how we build simple neural networks. So everything, whatever you design your neural network model, it has to come under INIT, and whatever the application or parameters what you do, it has to come under forward function, and you will return the X values. So did you understand?
Excuse me, sir, I have a doubt.
Yeah.
So you said that like we'll be defining a function like will it be like input to the output or between each layers?
Can you elaborate a little bit on that one? I didn't
Yes,
get
sir.
this.
Yes, sir. So like earlier you gave an example of x square function, right? So like uh, if there are if any function is there and we give input as a function and then we get an output and like the process will be there, right? There might be multiple layers between those. So will each layer have a different function or is it something different?
No, it depends on like what you do. Like if you have defined 128, right? So it will have only like 128, and each neuron is there, right? So each neuron has like its own operation as well. So that you define in forward and those kind of things. So each neuron, so it will be different, but it calculates most of the things. So in forward, whatever you write, every neuron will take the same parameters and those kind of things. So like what you do.
Okay, sir. And when we like do backward, we'll get the gradient of each layer, like of the process in each layer.
Yeah, whatever you do, right? Whatever derivative backward, like if you want to, you're doing this x, right? So if you take backward of this one, you should be able to calculate what operation is happening in each and every neuron. So you'll get those derivatives and gradients, like whatever you're doing. Those values will be retained and you'll get those as outputs. So you can check like what is happening in each neuron.
Okay.
So any other doubts? Okay. So this year defined something, right? So this is a neural network model. So whatever you design, uh, it won't be completely accurate, right? So anyone has seen any accurate machine learning model, ChatGPT makes mistake. Other things also make mistake, right? So everything is not perfect. So like in order to like calculate what mistake it's making, right? So we'll use loss functions. So loss function is like nothing but it's measuring how wrong your prediction is, or like tells you like how the model should improve from this wrong prediction, and it will correct on its own. There are multiple errors we'll calculate. So depending on these errors, like how we do the mathematical operation on each neuron, right? So based on different tasks, so classification tasks, if you are using for image classification, so we'll calculate different kinds of loss. If it is clustering, if it is regression, like based on the what kind of operation or what kind of calculation we are using or doing, we'll use different kinds of losses. So if you can see, there are three different losses which I mentioned. Mean square error, MSE, like used for regression task. Then there is cross entropy loss used for classification task. So image classification video task, like we'll use cross entropy loss. And binary cross entropy we use because only two types of classification would be there, 0 or 1. So whether it's true or false. So during that time, we use binary cross and entropy loss. So this is about loss function. Any doubts? Okay. So if you're not having any doubts, I'll go from the next slide. Okay. So we have defined the neural network model. Then we are trying to see like how much prediction is going on. So then comes the next concept of optimizers. So these optimizers are nothing but algorithms. So this one optimizers would tell like how the model has to understand from the loss and how it has to improve. So this is nothing but telling the model like you have made this mistake, and then you can correct it this way. Like that is what this optimizers is used for. So sometimes like we define this optimizers is like there will be some algorithms. So if you can see SGD, stochastic gradient descent, Adam is adaptive learning rates and RMS props. So root mean square propagation. So these are like most popular optimizers we use in order to reduce the losses. So if you want to get higher prediction or something like that, right? So what it does is like whatever the value you get. So there is something called as back propagation feed forward network. So whenever something wrong is going on, right? So you'll get those output values as an input once again. So you can correct that operation once again. So during that time, this optimizers is used properly. So it will automatically adjust your parameters and it will reduce your loss functions. So when I tell reduces loss functions, right? So you'll get some accuracies. So your prediction is 91% correct. Your prediction is 60% correct. So in order to reduce, if it is your 60%, 40% is your loss, right? So in order to reduce that one, we have to make it 95, 96%. We have to be accurate, right? So for that reason, we use optimizers. So this is used just to like kind of train the model to reduce the losses and make it more accurate and more predictable in classification and so on. So any doubts till this optimizer part?
Excuse me, sir. Yes, sir.
Yeah.
So when we are talking about loss, is it like how different it is from the label, or is it uh,
Sorry, can you repeat how different is it from?
like the predicted, or like the how, what it classified as? Like when we are calculating loss, does that mean like are we trying to find out how different it is from the actual output that we want, or like how different it is from the label?
Okay. So you have mentioned those things, right? I'll just explain in those terms as well. So labels are nothing but your human defined already existing values. So we are telling the machine, see this like these images are aeroplane, these images are birds, these images are fish. So take three examples. So what's the similarity between aeroplane and bird?
There might be a background of a sky or something.
Okay, one thing you're thinking about background. Okay. So aeroplane has wings, birds has wings. Aeroplane flies, birds flies. So there is a chance that if you give aeroplane image, the system uh, predicts as bird, right? At some point.
Yes, sir.
So like where it went wrong in predicting, that we calculate this loss. So for example, out of 10 images of aeroplane, your image calculated one image as bird instead of aeroplane. So your model is 0.9% accurate and there is loss of 0.1, right? So we are trying to use that some operation of this losses. So we'll calculate that loss and we'll just try to give how much loss it's getting on. So we use that loss function for this purpose itself.
Okay, sir.
So it's not like when you use loss function, it doesn't give 0.1. So in that, while predicting that last image as a bird, right? So at some percentage, it would have predicted aeroplane as 49% and bird as 51%. So there is like two different percentage variation, right? So for that, we'll try to calculate the loss, not the whole prediction. So where it went wrong in that minute calculation of classification.
Okay, sir.
Any other doubts?
Sir, can you once again explain like defining the function part?
Any function where?
Like building neural networks, right?
Okay. So there are what we do is like first. I'll just no. Don't worry about this one. Like I'll teach you in depth in next class. I'm just telling like three things you have to make sure. One is that whatever the neural network model we have designed, right? So if you see over here, we have defined one neural network model. So there will be inputs of 28 cross 28 images. So we are flattening that one. So 784 we are getting, and then we are telling in the first neural network model, there has to be 128 neurons. So coming into the second neural network layer, so 128 input once again, and the output has to be 10. So we are defining that. So this is like the neural network model which we designed. So from here to here. From here to here it's there, right? So this is the neural network model. So we are defining like how neural network model has to be there. So in self.fc, fc1 is like layer 1, fc2 is layer 2. This is nn.linear is nothing but it's a linear model. So it has to go only straight, don't look back or something like that. So then we'll define like what are the parameters is there under the forward function. So activation function, whatever we have to do, optimizers or loss function. So we'll just define in the forward, like define forward or something like that. Then we'll try to return the value. So when I recall this class, simple neural network module. So we can just actually have all these two things. So model and these parameters together and returning X value. So don't worry about this nn.module, nn.linear and those kind of things. We'll just go in depth in next class. So just understand inside in it, all your model design has to be there, and inside your forward, all the parameters and those kind of things related to your neural network model, it has to be there, and you have to return your model. That's it. Any doubts?
So I have a doubt about the like loss functions. So you told that like when it's like predicting and it predicts like 9% and like 1% it predicts like the aeroplane has a bird, then like if that's not done and it corrects like by itself, like if that's not done, then like will that be saved as a memory or something, and then it like next onwards it uses that like to predict the like further things.
Okay. So like what you told, like you as a designer, you have to make that neural network model, whether you have to like kind of correct from your wrong prediction. So if you define it that way, it will automatically correct. So it will try to predict next time as a aeroplane. So if you design like just leave it at that way, and like if you wanted to kind of don't want to optimize or something like that, so it will always try to predict as a bird instead of aeroplane for some cases, not every cases, some cases. So as I told, right, so for the last image, like it calculated one image as a bird instead of aeroplane. So while predicting that one, for bird it would have got 49% accuracy. So it's telling, sorry, aeroplane has 49, bird has 51%. So if you can see, there is a 2% difference, right? So like where you can correct, so it will like, try to look into this optimizers and loss function, and it will try to correct. So you have to define that. So how it has to learn from the wrong prediction.
Yeah, so got it.
Excuse me, sir.
Yeah.
Like talking about like loss functions, only I have one more doubt. Earlier you said that if like we get like 9 out of 10 times it's a bird and one time it's airplane, will it be like trying to get the accuracy to like 10 on 10, or like if you have outliers as you said like 49 and 51, like the confidence is not high, right? So like will it be trying to increase the confidence? Like will it both happen or only one?
No, like when you're defining something, right? So it will just do the task and leave it at. So you have to define like that confidence. See, this is not how it has to work. So you have to learn from these things. So like when you try to calculate the percentage or something like that. So at what percentage will you decide? So for example, at 49 percentage, I can tell this as the bird, and even if you get like 40 percentage, just give those values. So it depends. So like how we are defining the model and how we are defining like what parameters it has to have and at what value it has to predict, whether it has to rerun and try to learn from the mistakes it made. That also like we need to define.
Okay, sir. Thank
So
you.
it depends on the model. Like that's why like each and every time, like if you see Chat GPT 3, there was 3.0, 4.0 mini, 4.5, and they keep on increasing, right? So different versions. So this is what they're trying to do. So it made a mistake in previous versions. So they're trying to like learn new things and kind of give a better model. So any doubts till now? There are no doubts. So next class, like we'll go for training loop basics, like what this is and how we'll load the data, and we'll go more deep into the training of the model and how we'll design our model. So just try to understand like what was taught in today's class. So this was the basic, like what and all would be there in your PyTorch in order to define neural network models and those kind of things. So if you have any doubts, I'll just answer those. Any doubts? So I'll share this PPT with you also. Any doubts?
No, sir.
No, sir.
Excuse me, sir.
Yeah, Malya.
Sir, like what kind of model will be learning first, like classification or something else?
We'll do classification. So feed forward network. So
Okay, sir.
like when they started designing this AI, right? So machine learning or something like neural networks. So they started with perceptron. So perceptron is nothing but binary classification. So what they did is like they stack multiple of perceptrons and they created a feed forward network. So it has multiple like I just showed you, there will be hidden layers, input layers, and output layers, right? So there will be multiple of neurons in each and everything. So we'll try to see the simple feed forward network in order to classify simple images.
Okay, sir.
Okay. Others, any doubt?
Awesome.
Okay. Before you leave, I'll just take attendance just a minute. Okay. Just post it in the WhatsApp group. Yeah. Tanishka, did anyone attend and leave in between?
So I'm not sure, but like I can check in Zoom reports. Like I can even see the timings. I'll share it with you.
So just keep track in WhatsApp group. Abhishek was there. Sibinath is not there, right? So he's absent. So Ruben present. Pranava, did he come? No, right?
So he was there.
I'll take it as half present. Okay, fine. Okay,
Ex-
fine.
Excuse me, sir.
Yeah, Abhishek.
Yes, sir. Sir, about the assignment, Should we do tensor operations of addition, multiplication, matrix operations, reshaping tensors, slicing and indexing? Is that the assignment?
That is the assignment. So simple
Yes.
operation you can do. You can just practice.
Yes, sir. Sure. When should we submit it?
For next class. So make
Yes.
sure it's the output in WhatsApp group.
Yes, sure, sir.
Sure. Okay, I'll keep track of that assignment also in next class. Submitted. Okay, fine. So thank you everyone. If there are no doubts, we'll wind up this session.